So today we have an interesting geometrical problem. The diagram is on the screen with all the given details. And now the question over here is to find the value of the angle x. So this is Anmol Mishra, and now let us see the solution. How can we solve this problem? So first of all, we will mark all the possible angles in this diagram. So look carefully in this triangle over here. These two sides are equal, hence the base angles would have the same value. One of the base angle is already having a value 20 degree, hence this other angle would also have a value 20 degree. Now in this same triangle, by applying the angle sum property, the value of the third angle over here would be equals to 180 degree minus 40 degree. Hence this angle would have a value 140 degrees. Okay. Now look in this particular triangle, the base two angles are 30 degree and 50 degree. Therefore by angle sum property, this particular angle would have a value 180 degree minus 50 minus 30, that is 100 degree. Now look carefully, the complete angle is 140, sum part is equals to 100. Therefore we will finally get that this angle over there is 100 degree and this angle over here is 40 degrees. Okay. Now look carefully in this particular triangle. One of the angle is having a value 10 degree, other angle is having a value 50 plus x. Therefore by angle sum property in that triangle, the value of this particular angle over there would be equals to 120 degrees minus x. Okay. So here we have marked the missing angles. Now if we try to apply the angle sum property, the vertically opposite or exterior angles, in order to get the value of x, you will just get the answer as loop, like you will get x equals to x, or else 50 degree equals to 50 degrees, like this way answer you will get. You will not get the value of x unless and until you will use either trigonometry or either pure geometry, means drawing some extra lines and all that thing. So in this video we are going to use the trigonometric method. Okay, so we can say that this and this side lengths are equal, therefore we will mark them as variable a. Okay, and this particular side length over there we will mark it as a variable b. So now look carefully in this particular triangle, and what we are going to use is the sine rule. So remember the sine rule, if there is a triangle, the three angles of this triangle are alpha, beta and theta, and the opposite sides are capital A, capital B and capital C. Then sine of alpha upon its opposite side, that is A, this ratio would be equals to sine of beta upon its opposite side, that is equals to B, and this ratio would be equals to sine of theta upon its opposite side. So opposite to angle theta is C. Okay, so now let us apply the sine rule in this triangle. So it would be better if I label this diagram. So let this be point A, B, C and D. So first of all we are going to apply the sine rule in the triangle B, C, D that is present over there. So in this triangle, by applying the sine rule, we will get sine of x degree upon its opposite side, that has been taken as A. This thing would be equals to sine of 40 degree upon its opposite side, that has been taken as B, and this thing would be equals to sine of 140 degree minus x upon its opposite side, that is ultimately BD. Okay, now I will take these two pairs and do the cross multiplication. So I will get the value of B equals to A times sine of 40 degrees upon sine of x degrees. So here we have the value of B in terms of A and x. Okay, so keep this as the equation number 1. Now I will apply the sine rule in the triangle A, B, C that is over there. So this time the triangle is the triangle A, B, C. So in that triangle, applying this sine rule, so one of the angle is 10 degrees. So sine of 10 degrees upon its opposite side, that is ultimately B. This thing would be equals to sine of 120 degree minus x, that is one of the angle. So sine of 120 degree minus x upon its opposite side. So as per the diagram, the side opposite to this angle is AB. So upon AB, and this thing would be equals to sine of 50 plus x upon its opposite side, that is AC. So now over here I will simply compare these two ratios, and before comparing them I will simply change B with its value that we have got in equation number 1. So finally I will get sine of 10 degrees upon B, that will now turn out to be A times sine 40 degree upon sine x. So it will just go as multiplication, so into sine x equals to sine of 120 degree minus x upon its opposite side, that is AB. So now I will do some cross multiplication and get the value of AB upon A as equals to sine of 40 degrees multiplied with sine of 120 degrees minus x divided by sine of 10 degrees multiplied with sine of x degrees. So here we have got the value of AB upon A. Keep this equation as it is and label this equation as the equation number 2. Okay. Now finally we will apply the sine rule in the triangle ADB that is present like this way. So applying the sine rule in this triangle ADB, we can see that one of the angle is 100 degrees. So sine of 100 degree upon its opposite side, that is AB, this thing would be equals to sine of 50 degree upon its opposite side, that is A. So sine of 50 degrees upon A, and this thing would be equals to sine of 30 degree upon that side. So we are not going to take that ratio. Okay, that's not required. So now comparing these two equations, I will do the cross multiplication. So I will get the value of AB upon A equals to sine of 100 degrees upon sine of 50 degrees. Now recall the identity that sine of 2 times theta is equals to 2 times sine theta cos theta. So now in this identity, if I will replace theta as equals to 50 degrees, I will get the value of sine of 100 degree as 2 times sine of 50 degrees cos of 50 degrees. So I can replace sine 100 with this thing. In the denominator, sine of 50 degrees as it is, and this thing is equals to AB upon A. So now sine 50 got cancelled out. We finally get the value of AB upon A from this equation, that is 2 times cos of 50 degrees. So here we have got our equation number 3, that is AB upon A equals to 2 times cos 50 degrees. So now carefully look that equation number 3 is AB upon A equals to something. Equation number 2 is AB upon A equals to something. So both of these equations have the same left hand side. This means their right hand side is also equal. Therefore, 2 times cos 50 degrees would be equals to sine of 40 degrees multiplied with sine of 120 degrees minus x divided by sine of 10 into sine of x. So we can simply multiply that thing on the other side. So it will turn out to be 2 times cos of 50 degrees multiplied with sine of 10 degrees multiplied with sine of x degrees. So here we have got this equation finally. Now we have this particular equation, and to simplify this thing further, we will use the trigonometric identity. Recall the identity of 2 times sine of A multiplied with cos of B, that is equals to sine of A plus B plus sine of A minus B. So this identity we can simply apply it over here. 2 times sine of 10 into cos of 50. So it will turn out to be sine of 10 plus 50, that is 60 degrees, plus sine of 10 minus 50, that is negative 40 degrees. And we know this thing that sine of negative angle is negative of sine of that angle. So sine of negative 40 will turn out to be negative sine of 40 degrees. And this thing is still getting multiplied with sine of x. So into sine of x. Now on the other side we can see that sine of 40 as it is. Now I will change sine of 120 degree minus x. So recall the identity that sine of 180 degrees minus theta is equals to sine theta. So keeping theta equals to 120 degree minus x, we get that sine of 60 plus x is equals to sine of 120 degrees minus x. So in that equation, sine of 120 degree minus x can be changed as sine of 60 plus x. So finally the equation will turn out to be sine of x multiplied with sine of 60 degrees minus sine of 40 degrees equals to sine of 40 degrees multiplied with sine of 60 plus x. Okay. Now we can use the identity of sine of A plus B, that is sine of A plus B, that is sine A cos B minus cos A sine B. So in this equation we can change A equals to 60 degree and B equals to x. We will get the value of sine of 60 plus x equals to sine 60 cos x plus cos 60 sine x. Now we know the value of sine of 60 degree, that is root 3 by 2. So root 3 cos x upon 2 plus cos of 60 degree, that has a value 1 upon 2. Therefore sine of x degrees upon 2, and this thing is getting multiplied with sine of 40 degrees, and this thing is equals to the product of this term. So now sine of x into sine of 60 degrees, sine 60 has a value root 3 upon 2 minus sine x into sine 40 as it is. So sine x into sine 40. So now I will simply multiply the bracket on the right hand side. So sine of 40 is multiplied with two terms. The first term is root 3 upon 2 cos of x, so multiplied with sine 40 degrees, plus 1 upon 2 sine of x multiplied with sine of 40 degrees. Okay. Now I will simply shift this term on that side and this term on this side. So I will finally get root 3 upon 2 sine of x degrees minus root 3 upon 2 cos of x sine of 40 degrees is equals 1 upon 2 sine of x degrees sine of 40 degree plus sine of x degrees multiplied with sine of 40 degrees. Now these two terms are like terms, so adding them will finally give us 3 upon 2 times sine x sine 40. So let me write it over there. 3 upon 2 times sine of 40 degrees multiplied with sine of x degrees. Now we can simply cancel out this 2, 2 and 2. Multiplying square root on 3 on both of the side, we will finally get sine of x minus cos of x sine of 40 degree equals to root 3 times sine 40 degrees multiplied with sine of x degrees. Okay, now I will move this term on that side. So I will finally get sine of x degrees equals to root 3 times sine of 40 degrees sine of x degrees plus cos of x degrees into sine of 40 degrees. I can take sine of 40 degrees common from these two terms. So I will finally get sine of 40 degree taken common inside the bracket root 3 times sine of x plus cos of x. Okay, now on the right hand side I will simply multiply 2 and divide 2. Okay, now look carefully that root 3 upon 2 can be written as cos of 30 degrees. Okay, and 1 upon 2 can be written as sine of 30 degrees, so plus sine of 30 degrees and cos of x. So here we can see that sine of a cos of b plus cos of a sine of b. So by reverse of the identity, this thing will turn out to be sine of 30 degrees plus x. Okay, so now we can see that 2 times sine of 40 degrees multiplied with sine of 30 plus x. Remember the identity, 2 times sine of a sine of b is equals to cos of a minus b minus cos of a plus b. Now by applying the same identity over here, this thing will turn out to be cos of 40 minus 30 minus x, that is 10 minus x minus cos of 30 plus 40 plus x, that is 70 plus x, and this thing is equals to sine of x degrees. Okay, now to simplify this thing further, I will change sine of x in terms of cos. So sine of x can be simply written as cos of 90 degrees minus x. Okay, so now we can see that cos of 90 minus x equals to cos of this minus cos of that. So I will move this term on the other side. So finally we will get cos of 90 minus x plus cos of 70 plus x is equals to cos of 10 minus x. Okay, now we will use one more trigonometric identity, that is cos a plus cos b, that is equals to 2 times cos of a plus b upon 2 multiplied with cos of a minus b upon 2. Now we can simply apply this identity on the right hand side. So the right hand side will turn out to be 2 times sine of 90 minus x plus 70 plus x, and this thing will finally turn out to be 160 degrees. So 160 degree upon 2 is 80 degree multiplied with cos of no subtraction, therefore 90 minus x minus 70 minus x divided by 2. So now this thing will finally turn out to be 20 minus 2x upon 2, that is ultimately 10 minus x, and this thing is equals to cos of 10 minus x. Okay, now we can see that cos of 10 minus x is present on both of the side. So for the case 1 where we considered cos of 10 minus x not equals to 0, if we factor this out, we will get 2 times cos of 80 degrees equals to 1, and that is not true, because if we divide both of the side by 2, we get cos of 80 degrees equals to 1 upon 2, but we know that 1 upon 2 is equals to cos of 60 degrees. So this thing is not true. This means cos of 10 minus x is equals to 0. Now we know the value that cos of 90 degrees has a value 0, so we can replace 0 as cos of 90 degrees. Okay, now we have cos and cos on both of the sides, so we can simply compare the angles. Therefore 10 minus x equals to 90. We get the value of x equals to negative 80, and that's again not true, because x cannot be negative. But there is one thing, recall the identity that cos of theta is same as cos of negative theta. So if I replace theta is equals to 10 minus x, I will get cos of 10 minus x equals to cos of x minus 10. So this thing can be changed with this one. So cos of x minus 10 equals to cos of 90 degrees. Therefore, x minus 10 equals to 90 degree. And simplifying this thing further will give us the value of x equals to 100 degrees. And that's the answer that we were looking for. So finally, after using a lot of trigonometric identities and trigonometric simplifications, we got the value of x. And that was my way to solve this particular problem. If you have any other method other than this, to comment below. And if it's hard to comment, you can email me, or else you can send it to me on my Instagram. The link is in the description.